Today we're going to be going over the differential equations homework. So hopefully you've already tried this and now you're just going to be checking your work. The directions for the first two say find the general solutions. Now it does not say y equals f of x. If it said that, we would have to solve for y. These, however, do not say that, so we don't have to solve for y. I will, however, go over that just as a review so that if you have to do it on the AP exam, you've got a couple extra practice problems. So first thing we're going to do is we're going to cross multiply as usual. That gives me 6 minus y dx. Now I'm going to move this y over to the other side so I can separate my variables. So I'm going to divide it over. That gives me 1 over 6 minus y dy equals dx is the only thing left. So next step, we take our integral. Now the left side, I can't rewrite this. This is a u substitution because I have an inside part, which is the denominator. So I'm going to set u equal to 6 minus y. Du would be negative 1 dx. Oops, sorry, dy. So I have to add in a negative and take out a negative. So I'm going to rewrite my problem over here. That's negative integral 1 over u du equals the integral of dx. So the integral of 1 over u is the ln of u. And the integral of, there's really a 1 here, would be x plus c. Next, I'm going to plug back in for u, which is my 6 minus y. So technically, that is our general solution. We are done. We separated the variables, we took the integrals, we put our plus c in. Now, on the AP exam, if they do have this y equals f of x, we would keep solving. We would move that negative over first. So that would be negative x. It's still a plus c because it's still some constant. I'm going to do e to both sides. And we can move that c out in front. So we ce to the negative x. Now, next step, this absolute value could be any plus or minus value. So 6 minus y equals plus or minus ce to the negative x. I'm going to subtract the 6. So negative y equals plus or minus ce to the negative x minus 6. And then the last step, I'm just going to divide by the negative. Now, since this already has a plus or minus, the negative doesn't really matter, so it's still plus or minus. But that negative 6 becomes a plus 6. So again, you only had to do this first part, but if they say solve for y, you have to use your algebra skills to keep solving. Okay, next up, number 2. First thing I'm going to do is cross multiply. So we've got 2y cubed dy equals 6 minus x squared dx. And lucky for us, the variables are already separated now. So now I'm going to take my integral, add and divide. That gives me 1/2 y to the 4th. Over on the right side, we have 6x minus 1/3 x cubed plus c. So again, technically, we are done. We found our general solution. But just for practice, if I want to solve for y, first thing I would do is multiply the 2 over. So that gives me y to the 4th equals 12x minus 2/3 x cubed plus c, it's still a constant. And then I would take the 4th root. And with the 4th root, we need a plus or minus. So both of these are general solutions. This one is just solve for y. Okay, last question. This time we're going to find the particular solution. And if you notice in this problem they used y prime. Y prime, remember, is a derivative, so it's the same thing as writing dy dx. Sometimes they like to put that on the AP exam to make it kind of tricky. So hopefully you recognize that. So first thing I'm going to do is rewrite these radicals. So that's x to the 1/2 plus y to the 1/2. And I'm going to put in dy dx instead of y prime. And now I'm going to separate my variables. So I'm going to move this x over first by subtracting it. And then I'm going to just cross multiply that dx over. So I have y to the 1/2 dy equals negative x to the 1/2 dx. So I've separated my variables. Next, I'm going to take the integral of both sides. So I'm going to add and divide. So 1/2 plus 1 is 3/2. So 2/3 is going to go out in front. Same thing over here, but that's negative 2/3 x to the 3/2 plus c. So we've got an initial condition. So what I'm going to do, like on the AP exam, is I'm going to solve for y first. It usually makes solving for the initial condition a lot easier. So first thing I'm going to do is multiply both sides by this reciprocal, 3/2. That gives me y to the 3/2 equals, now if I multiply negative 2/3 by 3/2, that's negative x to the 3/2, and plus c is still a constant. And then to undo this fractional exponent, I can just move it over to the right side by multiplying by a reciprocal exponent. So there's my general solution. I'm going to just label that. Now I'm going to use my initial condition to solve for the particular solution. So I have a 0.19. I'm going to plug 9 in for y, 1 in for x. One thing to think about, this negative means that whatever we get over here, the answer is going to be negative. So 1 to the 3/2 is 1, but that makes it a negative 1. So now I'm going to undo this exponent, take a 3/2 exponent to both sides. Now, if you can't use your calculator in this one, the bottom number is the root. So the square root of 9 is 3, and then 3 cubed is 27. So that means C is, if I add the 1 over, 28. So my final particular solution, I'm going to go back and plug it in for C here, would be y equals negative x to the 3/2 plus 28 for C to the 2/3. So there is our particular solution.